Oh, it's so good. I want to rub it all over my body. I apologize for that little outburst. But oh my god, I want this thing so bad. I gotta upgrade my computer. I haven't upgraded this biatch in like 4 years. But enough about that shit. This is lesson I-13. And we're gonna do stuff with the platformer. Yes, we're gonna work on the sprite shit. I think my microphone has finally decided to obey, to behave. So I won't get any of that clipping bullshit that we had last time. Let me just adjust my volume level here. How's that? That looks good. Alright, so. Last time we did shit with tiles. This time we're going to do shit with Sprite. We're going to forget about tiles for a little bit. We're going to work on Sprite. The delicious, delicious flavor. I want a new item. Header file. Oh, don't forget to change that folder. Why did I ever do that? Okay. Sprite. Yeah. We had Pragma once. Class. So let's make a sprite class. There's just there's so much that I could do, and like so many digressions I can make, thinking in my head, what do I want to talk about, what do I want to cover. And then in the end you just gotta do it. Just fucking do it, man. Whether it's coding or making a video. After all the planning, you basically just gotta jump in there and flail your arms around like a retard. Well, at least that's in my case. So, what do we got for a sprite? We're gonna need... We'll need some position stuff, so we'll get a float X and Y in there. And what else? What we're gonna need, surface sequences, right? Yeah, we'll do that. So we're gonna need, first we're gonna need to include surface sequence. Sequence. We'll do a double pointer because we're going to have a pointer to an array of pointers. And we're going to call this one Seeks. No, not with an X. That is too retarded even for me. And what else? I can't think of anything else right now on top of my head, so that's what we're going to do for starts. For startsies. And... Actually, one more thing. Pointer to a surface sequence. Current sequence. So that'll point to the sequence that we're currently using. Because, I mean, you'll have different sequences for different, motions. Like for standing still or running or jumping. And that'll keep track of that. A lot of this stuff is gonna change, but I'm just gonna throw it out here, and we'll go from there. Let the chips fall where they may. This should be private. What am I doing? Private. All right. Public. What do I want here? Actually, this is not going to be private. This will be protected. Because we want the derived class to be able to do stuff with this. Public sprite. I don't even know if I want to make a constructor for this thing. Because I think we'll just do the constructing in the derived class. At least for now. In the way that we're going to do this up. What else do we want? Let's make a draw function, I guess. void draw. Oh, we're gonna need graphics for that. Oh, we get graphics with surface sequence, so we're fine. D3D graphics and const, because draw shouldn't change the state of the object, right? No, it should not. What else? It's fine. That's fine for now. Let's make a source file here. Add a new item. Sprite. You can do interesting stuff here, by the way. If you go project, you can go add class. And it'll add, I think it'll add the H file and the C++ file and other stuff, but I don't want to fuck with it. I'm fine the way things are right now. # include sprite. Alright, void sprite draw d3d graphics ampersand gfx const. I can't remember if I need the const here. I think I do need it there. That's fine. Okay, good. And we'll do what? We'll do current sequence pointer to draw. X, Y, G, GFX. All right. That sounds like that's a good idea. Okay. Now, let's make add new item. H file. Player's sprite. Add that up. Pragma once. I'm just gonna get like a sketched out overall little thing going here. A little bit of code here. Something I can get on the screen drawn, and then I'll start adding features to it little by little. So class player sprite public sprite. We need to know what a sprite is, so # include sprite.h. Yes. And I'll go back here, try to find where my, that's not it. Can't see my keyboard. Too much junk on my desk, microphone and so forth. That's not it. I'm never gonna learn how to type on a Japanese keyboard. That's not it. I can't blame that one on Japanese keyboard because that's whatever. What do we got here? Okay, so we want our constructor and our destructor for this one. Actually, we got to cover our asses here. Void or virtual void. No void. Virtual yeah, there's the tilde. Sprite. And we'll just make that like that. There. No, wait, that was stupid. Don't do that. Good. Probably not necessary, but just to be safe. If you don't make your destructor virtual, right, and you have a pointer to base class when it's actually the actual object it's pointing to is a derived class, and you destroy it, you will call the base class's destructor instead of the derived class, unless it's virtual, in which case you'll get the proper destructor. I've covered this before. You guys know this stuff. Alright. So, What was I doing? I was making player sprite. Okay, so public player sprite. Let's make ourselves a constructor, shall we? All right. X is equal to, I don't know, 100, whatever. Y is equal to 600 minus 25, I think. Yeah, we'll say, wait, 800 by 600. 600 minus what, 575 maybe? 575. There. All right. And what else? Surface sequence seeks equal to new surface sequence. There it is. Array 1. Yeah, is that good? Do you like that? How can you not like that? Much better. And seeks at 0, no, 0, no, 0, yes, equal to what? New surface sequence. Grr. What are our options? Ugh. Look at all that bullshit. std w string. It's starting to make my head hurt. Where's the thing? Does it have to be a long string or? God damn it. Let me see this bullshit. Where's my surface sequence? There it is. Okay, yeah, it does have to be a long string. Bah. Bah. W string L. Okay, that's fine. There it is. Let's see here. So we got L. Now, what did I call this bullshit? Stick, fall, jump, run. Okay, stick, stand. We'll start with stand. Stick, stand. Yeah. What else? Right, this way. Push this one here. End surfaces. 1. End hold frames. I guess 60. I don't know. It doesn't matter. It's just the same frame every time. D3D color key. I think that's defaulting to white, which is good. Good. Alright, so there's our constructor. Oh, wait. Current sequence equal to seqs. That's 0. Which is redundant, this thing I'm doing right now, but who cares? Where's my ampersand? It's on the 6. There, good. Okay. Perfect. Except not quite. because I don't need this. It's an array of pointers already. Alright, so that is our maker. Now we make our breaker, which is virtual. And we go delete 0 and delete the array seqs and done. So here's our very simple sprite. I'm going to make my Y 400 for reasons. Alright, let's build this mother. How many errors can we get? Failure. Alright, where's my failures? Modifiers not allowed on non-member functions. Draw. Void sprite draw. I'm gonna say I don't need the const here. I thought that might be the case. Still not happy. Sprite struct type redefinition. Okay, somewhere I defined a sprite structure, and that is not making us happy here. Where is it? D3D graphics? Do you have a sprite? Oh, yes, you do. Now here's where you get your namespace collisions, and this is where it's actually really nice to have using namespaces, because if I had this under like a D3D graphics or GFX namespace, then I wouldn't have to collide. I would just not use and using GFX in my other file here, and it would be all fine. But I'm not using namespaces right now. The more important thing here is that I don't really need Sprite anymore. I don't need this load sprite bullshit, because we're loading with although now that I think about it, what is this thing using? Surface sequence. What does Surface use actually? Okay, so Surface does not use the sprite routines. It does everything by itself. That means that the sprite routines are now redundant. Let's get them the fuck out. Where is graphics? It's in the framework. D3D graphics. Okay, what's your sprite? Sprite, you're dead. And font, I'm looking at you. Giving you the people's eyebrow. Okay, we don't need any of this bullshit. Die. Okay, and that's that. So that's that for the H file. Now we go to the other file. Where's the bullshit? Okay, load sprite? No. Free sprite? No. No, no, no. What's your problem now? Okay, you're fine. Good. Okay, so now that we finished that, cleaning house a little bit, let's try to rebuild. What do we get? We still get failure. Of course. Of course. Error, syntax error, identifier sprite. Okay, we still got bullshit over here. Draw sprite alpha. We don't need that. Rebuild. This is what we call refactoring. Kind of. Okay, overloading it now. Now it probably wants the const because it did need it after all. I was right the first time. Still got failures. Draw sprite is not a member of... Ah, okay. Yeah. Okay, I got you. I don't bother looking through my code trying to figure out what's wrong. I just make the compiler find all my mistakes for me. And we're... not found by performing full link. That's weird that didn't not work. Okay. That's fine, I guess. Alright. Now we cleaned house there a little bit. Let's get on with it, shall we? Where is my game? There it is. Game.h. First thing we're going to do is we're going to get rid of this surface sequence. That was just a little placeholder for before we actually made a proper sprite. But now we have a kind of sprite classes, the beginnings of a sprite class. Let's include player sprite. We'll create a player sprite here. Call it P. What's this S? S is probably the surface sequence, which is no longer existing. And neither is all this bullshit. Oh yeah, we don't need X and Y either. We don't need that either. We don't need you. You go away now. Go away. Okay, where's the other thing that we don't need? All of this stuff. And P doesn't actually take any arguments right now. It's just a dumb little derived class for my pleasure. For me to pleasure myself. Okay, now we gotta try drawing it. Let's go p.draw. Seems okay. And let's see if that works. Build. Crash. Not good. Not good, my friends. This is not returning. We're off to a rollicking start, as they say. So what could be the problem? I'm thinking probably didn't load the sprite properly. Probably did not load that surface sequence. Which means what? Exactly. File name not right? I'm guessing file name because I did not put in there the folder. Stick stand. Okay, so file name and folder all wrong. Chili for the fail. Double backslash stand. Let's try that out. Build. Run. Okay, so now we got our dude here. He's standing in the middle of the air. It's a start, people. It's a start. Take a little break here. Alright, friends and Romans, I am back. Let's get on with it. What do we got here? I guess I don't need to say that because for you guys it was only like less than a second. So we got our dude. He is being rendered to the screen. What's next? Well, there's lots of ways we could go. But I want to deal with something that you guys probably haven't thought about yet. And that is what X and Y actually mean for our sprite. So if you look on our screen here right now, X and Y are probably this point here. This is our coordinate. And based on this point, our sprite is being drawn from here. But when you think about it, like this point is, it doesn't really mean much to the game in terms of like collision or presence of the character. I mean, normally when you say an object is at a certain coordinate, you don't mean like a corner of the object is there. You probably mean something like its center of mass is at that coordinate, or perhaps its point of contact with the ground. Those would be much more rational points to base your location at. But because we draw starting from this corner here, we just tend to default to the top left corner. But for our sprite, we're going to redefine the point of reference to be somewhere between the two legs here, basically in the vertical center and at the point of contact with the ground. So we want to redefine our point of reference. How are we going to do that? Well, we're going to do that by editing our surface sequence class here. We're going to add I'm thinking probably int, but yeah, I think int. We're going to make it not unsigned. We're going to make it as just a normal int, signed int. Base x, base y. So these are the base coordinate for our drawing point of reference, and minus base y. We'll translate these, we'll transform these points by translating them by base x and base y. And one more thing. I'm going to have to add even more stuff to this. So we got int base x and int base y. This parameter list is getting too long. There we go. Stop that. We'll go down here. We'll go base x, base x. There. And now we gotta go to the place where surface sequence is being created, which should be at our player sprite thing here. And we gotta add bases here. So, where exactly are our base x and base y going to be? Let's go to this folder here. We'll go to stick stand. Open this up with, I'm going to open up in Paint because Paint, I like Paint better for this work. I'll just zoom in there a little bit. I'll pick my eyedropper. Doesn't matter what tool you pick. I'm going to minimize this a little bit here. Get it in there so you guys can see. So we can see our coordinates down here. And I guess I want my my base point to probably be right here, which is 1159. Seems pretty good. So I mean the whole thing is 25. Could go even for here. 1259. That seems pretty good to me. I'm gonna say 1259. So 12 is the x, 59 is the y, and that's probably, no, that's fine. How's that? Oh, no crashies. Okay, now obviously our sprite has moved. Now his head is stuck into the thing here. So now let's redefine the position. X100 is fine. I'm going to bring this one back down to 575, which should put the Y position right on the top of the very bottom layer. So he should be standing now on that thing there. Visually speaking anyways. Doesn't mean anything in the game because we got no interaction. There you go. Now he's standing on that. If I go one higher, which means this number gets lower, interesting. Three. Maybe I should make this one 60. Or 61. Now I'm getting confused. 60. Please be a 0. That was an 8. Off by 2. That's fine. Okay. So we've centered our position there. We've zeroed in our base position on this surface sequence. What is next on our to-do list that I did not make? I guess we're going to want to be able to move this bastard. And that is going to require us to have states. Because like I said before, we're going to be driving this motherfucker with a state machine. So we're going to need states. Let's get on that shit right now. We're going to make a new item. Sprite state. Header file. Alright. Class. Sprite state. Protected. What do we have for protected variables? Nothing. Nothing as of yet. I can't think of anything off the top of my head, actually. Oh, that's not true. Definitely got something we want. We want a pointer back to the sprite. Because we're going to need to be able to access the sprite in order to, do stuff with it in our state machine. Pound sign. Sprite.h. There we go. But what else we need? Public. Okay, we're going to need virtual functions for each of the events that our state machine will respond to. So, for example, virtual on what should we do this? Command? Control? On control, write down, which means that right has been pressed, the right motion button has been pressed. Yeah? Like that. seems good. Let's start with that. What other command would we want? That's it for now. I'm going to start simple. Now here's the problem. The sprite state class is going to want to have to change stuff in the sprite. Especially it's going to want to have to change, the sprite class is going to have to include sprite state. And sprite state is going to want to include sprite. You can't do that. What you could do is go up here and just go down here, class sprite, pointer to p sprite here, and then in the h file you would actually define, you would actually include sprite.h so that you could use it. But here you just use a forward declaration, and that would break the chain of the circular dependency here. But you still got a problem in that we can't actually access anything in Sprite because it's all protected, right? We can only draw it or delete it, and we don't want to do either of those things from the state machine. So how do we allow the state machine to access a sprite while still making it so that other stuff can't access the sprite's goodies? That's the question. There's a few ways you could do this. I've explored some of them in my head and in code. One of them is you can make sprite state a friend of sprite, and then sprite state can access all of the protected members through this pointer if you make it a friend. But the problem is that sprite state is only going to be the base class, and where the actual work is going to be done is in the derived classes, for example in running state or standing state or whatever. So that means now you could get around this, and all you would do is you would make in sprite state, you make a bunch of protected functions like for example float get x, and then you just return p sprite pointer to x, and because it's protected, the children can access this function to get at the internals of sprite. But you have to make a function for every variable in sprite, and that can get annoying and everything. I have a different solution. I'm sorry if I didn't explain that, really super in detail, but it's not really a avenue we're going to explore, so I don't want to waste too much time on it. My plan instead is we're going to make a new class here. Header file, and we're going to call it Sprite Core. And again, pragma once class Sprite Core. And this class is going to contain all the stuff, all the main stuff about Sprite that we want to share with our state machine. So I'm just going to copy these guys here. Actually, I'm not going to copy Sprite state because that's not important. Where is it? I'm going to say sprite state is not important. Yeah, we'll just do this for now. Copy that. Whatever. Whatevs, dude. Let's go to Sprite Core. Paste that. Delete. Enter. And we'll go back to Sprite here. We're going to get all of this bullshit. Cut that. Sprite core, paste that. And we're going to make all these variables public, which is not something you would usually do, but we're going to do it anyways, because that's how we roll. What else do we want to do? That's fine for now. That should be sufficient. So we include surface sequence here, make our sprite core. Let's add something to sprite core. Let's add class sprite state. Pointer to state. Make a forward declaration of a sprite state here. So we got this class, and it's just got data. It's basically just a structure right now, but all the data is public. So it really is just a structure. Now in Sprite, we go protected, Sprite core, and we define a core. We've got to go up here. Sprite core.h. And now, because we did that, we got to go to sprite.cpp, and we got to go core dot current sequence, pointer to draw, core.x and core.y. So we got to do a little bit of dereferencing there, or I don't know, member selection, whatever you want to call that bullshit. We doing it, and we got to go to sprite, player sprite here, and do the same BS core. Now you may think that this is, you know, cluttering up our sprite code, but believe me, most of the work is going to be done in the state machine. This is going to make the state machine prettier. Ostensibly, I haven't actually used this approach before. In my test code, I used the approach that I just described, but I like this idea better, so I'm going to stick with it. All right. So here is Johnny. And here's our sprite state. Now if I do it like this, I don't need sprite state in here. All I need is sprite core, really. I'm just trying to figure out my my dependencies, what I'm going to need to do here. Which ones we'll need, because the more I can cut back on like forward declaration, the better. I don't like to use forward declarations unless I have to. Just a policy of mine. I'm not sure whether it's founded in anything, but just the way I like to roll. That's how I roll. So we got, let's include sprite. Wait, is this sprite or is this sprite state? I think this is sprite state. So let's include sprite and see if it doesn't break anything. Nothing broken yet. And sprite core. I think that should be fine, really. We'll see what the compiler, if it chokes on it later on. I don't want to think of things too hard. I might give myself wrinkles. Okay, let's change this pointer here now, because pointer to sprite is useless, right? Inside of our sprite, sprite core is protected. If we have a pointer to sprite, we can't get at sprite core. But if we have a direct pointer to a sprite core, then we can get at the goodies of the sprite in which that sprite core is embedded. And that is what we're going to have in our state. A sprite core, pointer to sprite. Yeah. My terminology is a little inconsistent. Sometimes I put a P something to show it's a pointer. Sometimes I just don't put the P. That's bad. That's a bad habit. Like here, it should be P state, right? It's just state. Why aren't you P state? You should be P current sequence, but you're not. Because I didn't do it. I'm going to make myself consistent. I'm just going to put a sprite here. Although, I suppose that that little P in front is actually pretty useful. Self-documenting and so forth. So I recommend that you maybe use it. I don't know. You guys got to figure out your own ways. I'm just going to try to be consistent. Probably fail, but you know, that's the way it rolls. So, I got a sprite state. I got one event that it'll handle. I got a pointer to a sprite core. We're going to need a whatchamacallit, a constructor. So I'm going to make one here. I'm going to call this one, it's not virtual, it's just sprite state. I'm just going to put the constructor in here because I don't want to make a separate CPP file for this because I don't think we need one. It's just going to be a pure virtual, what do you call it, an abstract class. That's what it is. That's my words I was looking for. Sprite core, pointer to core, sprite core. Done. Done. Done and done. Okay. Not quite done, because I didn't do it. There we go. Is that good? Do you love me now, mommy? There we go. That's my favorite kind of way of writing stuff. Nobody writes it like this, but chilly. Okay, so yeah, that's fine, right? I don't even really need this, but it's nice to have. So we got our base sprite state class, and this is all it is. That's the class. Now we're gonna make a derived class here. Let's get derivative. I'm about to get derivative on your ass. I'm going to call this the, how shall I name? I could call it standing state. I could call it sprite standing. I could call it player standing. That's how I named them in the other one. I'm going to name them the same way. Alright, pragma once. You see how when we make separate files for different classes, things get mixed up really quick. Which is why folders will come in handy. But even then, my friends, we're still fucked. Include sprite state. Class. Sprite standing. Public. Sprite state. No, my friend. Bad man. What do we got here? Sprite standing. We're gonna do it like what? What am I doing? What am I thinking of? I guess I need a sprite core pointer to core. Bah. And I go sprite state core. There's one kind of constructor. We'll have another one later. Never fear. Now we have to what? We have to publicate. That's a technical term. And we gotta void our bowels. I mean, make our void function. On control. write down virtual. You don't have to say virtual in the derived class, I don't think. But it's good. It's good practice. I like it. I like to do it. Do some more. Alright, now I feel like that's all we really need for this one. Yeah, that sounds good to me. Now we need another state. We're going to make another file. And we're going to call this player running. Make the header file player standing. I'm just gonna copy all this. It's time for copy pasta. And then I'm gonna change this to running. I'm going to copy it. There's my C. There's my thing. My ding-a-ling. Everybody's thing. And yeah. So that's basically the beginnings of something. Possibly. What else do we want? Now, I guess we want to start doing things. What's that thing? Programming. Yeah, that's what it was. We should program some stuff. Let's do that. Let's start to add a new item. Sprite standing. Make a CPP file. Sprite standing. # include. Wait. Fuck! Trust me, it's hard to talk and do anything else at the same time, especially when you're retarded. Save changes, no. I want to delete this. Remove. Fuck! Is it still there? I didn't save it. Oh, that's the wrong one. Let's see if it's still here. I know you guys enjoy me bumbling around like this for no good reason. Sprite standing.cpp. You go to the trash bin. Get the fuck out. Thank you. Okay, let's try that again. This time let's not fuck it up. I'm so not editing that out, by the way. Ain't nobody got time for that. Alright. Player standing. Much better. # include player standing.h. Okay, so let's program. Void. Player. Fuck you. Fuck. Player standing. No, I'm just pissed off. What the fuck, dude? Okay, player standing. Player standing. Virtual void. What the fuck, man? Seriously, I'm getting pissed off. Why are you not doing your job? Fucking bullshit. I'm probably doing something really stupid. Fuck it. On control. I'm starting to get hungry now. On control write down. Okay. Just make that empty for now. Because I gotta figure out why this thing is fucking. Feeling burpy. Yeah, let's just try building this shit. We'll get rid of errors. We'll get shit. We'll patch it all. Make nice with the. It's not a class or a namespace name. The fuck it ain't. Player standing. Player standing. Sprite standing. Well, fuck me in the ass. No, don't do that. I changed my mind. I do not want you. That's not the thing I want you to do. But I deserve to be chastised. Subconsciously, I just want to make it Sprite for some reason. I just like Sprite. It's fizzy. It's effervescent. It's refreshing. What am I saying? It's Sprite, you know. How is this now? Are we... Okay, we're cool now. We are cool with the compiler. Awesome. Okay. So what happens on control write down? Well, when we do that, what we want to do is we want to change states to running. So we're going to go core pointer to Sprite pointer to. I'm going to learn it. I'm not going to change it to core. I'm sure I'll figure it out eventually. And what do we got? Yeah, because we call it core in Sprite, but then we call it Sprite in state. That's going to cause problems, isn't it? I know it's going to cause problems. I'm going to fuck that up all the time. Let's just admit that we fucked it up. And by we, I mean me. And change it. In Sprite state. Sprite state. Here we go. Change that to core. Change that to core. And that's it. That's all we need to do. Problem solved. I'll never do that again. Just forget I ever called it Sprite. The refreshments will have to wait until after the tutorial. So, back again. Core state. So we'll change the state. No. Make a temporary Sprite state. And we'll make it into a new how's that? We'll make a new player running state. Is that what we want to do? Or do we want to do this? Sprite state temp is equal to this, the current state. Or do we want to not make a temp at all because we don't need one? Sorry guys, I'm just thinking in my head here. We got to create a new state, and then we got to change what the sprite core is pointing to. So I think we can do this without a temp variable. All we got to do is go core pointer to state is equal to new player running. And we still have a pointer to what core.state used to point to because that's the this pointer. So we can go then delete this. So we change the state and then we delete the old state. Seems pretty good to me. And now Now what? Well, let's do the player running. Player running. New item. Make a CPP file. Player running. Player running.h. And again, void player running on control right down. That's fine. And we're not going to do anything, because if we're running, we don't care about pressing the key. It doesn't matter to us. So this will, when we press the key here, when we send the control message, that will So we got our sprite, and it has a core, and that core has a pointer to a state, and state, we currently have two states: run, stand. So this can point to either one of these. This can be either one of these. Now state is going to respond. It's going to have functions like fucking on write. So we're going to need some kind of a entity that will call the event functions. That entity will be like a controller. And that will actually call the command functions like on right or on left, down. And for us, that'll be, you know, something hooked up to the keyboard. So I'm just wondering now if I should introduce interface kind of architecture to you guys, or if I should hold off on it and introduce it later. I think I'm going to hold off. I'll introduce it when it becomes necessary, because that will make it more clear why I'm doing it. So for now, we're not going to have that. I understand that I'm mostly rambling to you guys, but this will become clear in due time, or it won't. One of those two. Okay, so yeah. Now what we're going to need is we need another event here. And this is not a control event. This is, fuck that, Sprite State virtual void on update. This one just tells us we gotta update our shit. We gotta move that motherfucker. So it's not an event like from the keyboard press. It's just something that happens. Update will happen once a frame, right? This is your once a frame update of your sprite's status, dependent upon its current state and other shit. So we gotta implement this one. Let's just go sprite state, virtual void on update. Copy that. Okay, so player standing. That one's going to be simple because we're not going to do anything when it's standing. But when the player's running, we're going to want to do shit. So let's go to players standing. Now I could type void players standing blah 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 and then make an empty function for update. But I'm not going to do that. What I'm going to do is I'm going to go into sprite state. And I'm going to make on update, instead of making it a pure virtual function, I'm just going to make it an empty function. And that means that children classes who do not override this will just default to the basic, the fundamental behavior of doing nothing, which is fine. Okay, so that means I don't have to change anything for standing, but for running, player, why do I always get that fucking, it's because I suck at typing, doesn't it? Doesn't it? Wow. I am falling apart here, guys. Player running on update. There we go. So on update, and we're just gonna make our sprite right now so it can only run to the right. We're gonna on update core pointer to x plus and equal 1.5 float. So when we're running, when we're in the running state, we're going to be moving to the right by 0.5 a frame, which is 30 pixels a second. Not going to break any speed records, but it'll be perceptible. Build solution. Somehow I don't think why did that succeed? I'm fine with it. I'm fine with that succeeding. Yeah, that's fine. Right. Nothing should have changed because we don't have a controller hooked up to the sprite state. Now here's the thing. If I can find my what thing. Controller will not actually hold a pointer to the state. Why? Because when the state changes, like for example when it changes from run to stand, let's say this is run, change to stand, this gets deleted, and this pointer will become invalid. So we can't point directly to the state that the controller is controlling. We have to point to something else. We could point to the sprite or to the core or directly to the pointer. Either one would be fine. I'm going to point to the sprite just because core, what a pointer. I'm going to point to the pointer to begin with for this controller. I'm just thinking how I want to do this. It's not that important because it'll probably change quite a bit for you guys as I refine. Whatever, I'll just point to the sprite. Yeah, I'll point to the sprite to begin with. We'll change it later if we feel like it. You'll see what I'm talking about. We're going to make a new class. Because we don't have enough. Not nearly enough yet. They don't call it object-oriented programming for nothing, man. We're going to class this bitch up. Sprite Controller. Let's make a controller, shall we? Pragma once. Alright, class Sprite Controller. Bam. Protected Sprite pointer to Sprite. Ooh, burps. Sign include sprite.h. Include sprite state.h. Okay. Public. Also want to. Okay. Keyboard.h. Because the controller is going to have to interface with the keyboard in order to figure out what kinds of, shenanigans have been, and so forth. So we need a keyboard. KB. That wasn't good enough. Not quite. Keyboard client. That's fine. Okay. Sprite controller. Yeah. Sprite pointer to sprite. Keyboard client. And KB. Nope. This one. Sprite. KB. Yes. Yes. And void poll. The poll function will check the keyboard, see if there's anything happening, and if there's something happening, it will dispatch that event to the sprite. How is that? I'm going to make this a reference. Even though I don't think it should be a reference. But if it's a problem, I guess I could change it later. Although it would be a big pain in the ass. Fuck it, I'm making it a reference. Yeah, I'll make it a reference. I'm just thinking, like, I might want the controller so that I can make it, I can switch the sprite that it's controlling. Like, imagine just, in your heads, like, if you've ever played, like, Abe's Odyssey, right? You can possess enemies and then move them around. And that might be implemented in code by changing the sprite that the sprite controller is pointing to. But you know what? We'll worry about that. We'll cross that bridge when we get to it. I am not a big fan of forethought. I like jumping in gung-ho. So let's Because we gotta actually write code now. Hate it when that happens. Sprite Controller. Include, no, Sprite Controller.h. And yeah, okay, so what functions do we want to mess around with? I guess poll, right? So void Sprite Controller poll. KB. You know what? Fuck KB. Fuck it. Where's my Sprite controller? Here it is. KBD. D. There. Because that's what I call it in main, and I'll probably fuck myself over by mistyping it all the time. Okay, back to where I was, which was this. Yeah, keyboard. Alright, so on the poll, if KBD dot, what do we got? Keys pressed. Peak car. Read car. We don't want keys pressed. Flush buffers. I'm pretty sure that null means that there was no character being pressed, right? Blah. Wait a second here, I'm gonna just check something out. Oh, sorry there, I just had to grab myself some comestibles, because I'm starving here. I've consumed the last of my provisions. This may be the last YouTube video I ever make due to my dying of starvation. Alright, so we're pulling shit. I'm sure I could make a joke there filled with innuendo, but I won't. I will abstain. So we want to do a switch here. If it's not, yeah, we'll do it this way, right? We'll say switch kbd dot read car. Is it car or is it key? I think I want key actually. Big key and read key. Case virtual key write. And if it is a right button key press, we want to go Sprite that's odd. Sprite. Now here's the problem. I can't get at the states here, so we're going to add a function to Sprite. Sprite state and get state. I can't do it in here. I gotta do it in the CPP file because I don't have Sprite core defined up there. Or do I? Actually, I probably do. Yeah, whatever. I've already made the switch to this file. Might as well put it in here. No. Thing about where is it? Sprite.h. Yeah, Sprite core is up here. I can do this. The thing about defining your functions in your H file bullshit. Dot state is that it allows the compiler to inline the functions, whereas if you put it in the CPP file, it traditionally was not able to inline them, although compilers today might be able to inline one CPP file function into another. But before, only the functions that were in the H file could be inlined into other CPP files. So I'm not sure about the status right now. Why is this underlined? Right. How about that? That's fine. Yeah, because this is a pointer, but I'm returning a reference, so I need to dereference the pointer first. That's fine. Okay, now I can go back to my Sprite Controller down here, and I can go sprite dot get state dot on control right down break. There we go. So we're just going to handle this one here for starters. I'm not sure if I'm happy about exposing state like this to the outside world. That's not something I might be happy. That might not be something I'm happy with. But we'll do it for now, and if I change my mind later, then we'll switch it up. We will refactor. There's going to be a lot of refactoring, guys. Mostly by design here, because I want to show you guys refactoring, because when you guys do your own shit, you're going to be refactoring a lot, I imagine. So you're going to need to know how to do that shit. I can show you at least one version of how someone does it. It's better than nothing, ain't it? Okay, so now we got our controller. Make sure everything compiles. Okay, now we have our controller, we have our states, we have our sprite. I know I'm missing at least one thing because I left it out on purpose. Let's see if we're missing anything else. Where's my game? That's what I wanted. Okay, so Sprite Controller is going to be outside of the sprite. It's going to be another loose object in the game, in the main game object. I might want to make it more integrated into the sprite itself later on, but for now it's just going to be a loose, just a loose stool controller. Call that C. And we'll go into game.cpp. This is important, by the way. You have to put this one at the end of the variable list. And why is that? Because, well, it's not super important, but the order in which embedded objects are initialized depends on the order in which they're declared, not this order here. Little known fact. I've probably mentioned it before, but it doesn't hurt to mention it again. Controller. So we want T Why did I name it T again? I don't even know. That's not what I named it, is it? P. Right, P. Because P isn't in here. That's why it messed me up. And keyboard. KBD. There we go. So here we have the controller all set up. Well, there's at least two things that I've left out doing here. Let's see if you guys can figure out which one it would be. Compose frame, end frame. So here we want to controller.poll. We want to poll the keyboard and dispatch any interesting key presses to the sprite. And we can do that and draw it. Now this is not going to do anything. So let's see if you guys can figure out why. Feel free to pause the video and try to figure it out on your own. But here I'm pressing the key. Oh, it did something. Okay, this was not something I expected, but I'm not exactly surprised either. Get state seems to have fucked up. I would imagine it was get state that fucked up. Break. So sprite is fine. And the core is pointing to... The state is not set up. Well, there's problem number one. We don't initialize the state in our... sprite. Player sprite here. And that is definitely a problem. So let's do it. We'll go core.state is equal to new player standing aha. Yeah. New player standing address of core. How's that? How do you like them apples? Pretty good. Okay. And here we'll go delete core.state. Okay. So that is problem number one, which, to be completely honest, I just forgot that. I just totally forgot that bullshit. That wasn't one of the things I left out. On purpose, like. On update. Player standing. Player standing. Yeah, we don't need that because we're just going to use the parents version, which is the do nothing version. Build. Done. So what do you think's gonna happen now? Take a guess. I'm gonna push the buttons, pushing the buttons, nothing's happening. That's what happens. Nothing. Why does nothing happen? Well, two reasons. Well, one reason, first of all. Two reasons. First reason, we are not updating the sprite. We have to call the sprite state's update function. Now what I probably would want to do is just make an update function in the sprite, and that update function will, among other things, call the update of the state object. But for now we'll just use the get state to access the state and then call update from there. We'll worry about other things at a different date. So we'll call this, we'll process the keys, and then we'll call p dot get state dot on update. Fuck you, bitch. On update. Now this should make things a little better. Or maybe it'll just cause me to crash again. That's also a possibility. I won't lie. Alright, now we're moving. I pushed the button and we're sliding across there. We are not running, however. And that is also something that I expected. Reason being that, let's see, where's my shit? Player standing here. We change the state. On button press we change the state, but we don't change the whatchamacallits. The who's-its and what's-its. The surface sequence. So we have our surface sequences, and we have our array of sequences. This is current sequence or whatever, I don't know. And it's pointing here, and we change our state from, stand to run. But this is still pointing at the stand state, so we're just going to slide across the ground. It's not going to look very pretty. It's going to look dumb. Also, it doesn't help that we only have one option here. We only have one surface sequence, but I mean, even if we add other ones, we still got to change what the current one is pointing to. Let me show you what I mean if I can figure out where I'm supposed to be. Player sprite. Here we go. So here we only create one. Let's create two. And let's copy this here. One. We'll call this one stick run. And run. Now I've got to remember what all the parameters are for this one. And in order to do that, we'll look at my my little prototype here that I was working on. We'll go, where would it be in my prototype? Probably be under player, probably be under factory. Player factory? Yeah, there it is. Oh, look at all of these fucking files, man. Look at all these files. We're going to make so many files. Oh, you're going to love it. Okay, running. Stick run, and numbers. Lots of beautiful numbers. So that's 13 frames of animation. 4 frames per frame. Something. Oh, this is the base numbers, right? 38 and 58. Those are the base coordinates on the bitmap. All right. So now we have our two surface sequences. Delete that. Current sequence is equal to 0. Now here's the thing. I don't like having to change, like for example, I don't like having to set the current sequence to being 0 in the constructor here, and then for example in player standing, set the current sequence here. That is a pain in the ass. But I'm not exactly sure where I want to set it. I mean, it's got to be set when we do the change, so I can set it here. But the other thing I could do is I can go to just randomly jumping now. Sprite State here. Or I can go to Sprite Standing. And yeah, player standing, not sprite standing. So when we create this state, we get a pointer to the core. In the constructor, we can tell it to go core, pointer to man, I could have made this core a reference. I feel like I want to make it a reference. We'll think about that later. We're just going to finish this video. We're already an hour and a half in. Change current sequence is equal to core pointer to sequences at 0. So whenever we create a player standing, it'll automatically set the sequence for us. We don't have to remember it. That is a good place to be at. And player running, similarly. And by similarly, I mean copy-pastery. Oh, that was cutty-pasty. That was something else. There we go. Core current sequence, change this one to 1 because running is a 1. That's looking better. Better already. Let's try that. Ooh, I'm going to change one thing first. Player sprite. Get rid of this because we shouldn't need it, right? The act of creating a new player standing should, in theory, set the current sequence automatically. I'm going to do something else first. I'm going to set the running speed by going to player running. I'm going to set that to 2.0. It'll look slightly less dumb when he runs. Oh wait. It still looks dumb. Why is it doing this? It's a little better. Slightly better, but it's not really good. It's not what you would call dynamic animation there. So what's the problem? I'm sure you guys could probably figure it out. So we got to go to player running. And we got to go core pointer to current sequence dot. Nope. Pointer to update advance. So we gotta advance that that sequence. Note that we don't have to advance the standing one because it's not animated right. Let's try this. Oh yeah, he's kind of looks like he's running against a headwind, but he is running. And that is, I think that's all we're gonna do for today. It's a good place to stop it. We'll continue on hopefully next week. I want to try to get 1 week out, but not making any promises here. Definitely not. So next time, I guess the next problem to work with is the fact that once we start the dude running, he just keeps going forever, which could be a problem in a game. So perhaps we'll contrive a way to have our guy stop. And lots of other crazy shit. At least now I have like a a set goal, something to go on. I don't have to think about what I'm going to be doing. I just know what I got to do. I just got to do it. So yeah, we'll get more programming stuff going on next time. Until then, it's Chili signing off.